Okay, so we're going to learn how to factor by grouping for your A-level practice. So this is on the back of your Solving Polynomials pink foldable. If you haven't taken it out yet, please take it out. So it's very similar to the factor using the distributive method, and factor by grouping we might have called it already. Key basis of this is your grouping. That's why it's called factor by grouping. You group the first two terms once it's in standard form, and the last two terms when it's in standard form. And then you just find the GCF of each. So the GCF of 8x cubed and 64x squared. Well, 8 and 64, I could take an 8 out of both of those. And then x cubed and x squared, I could take out an x squared because they both have an x squared. So when I divide that out, remember I got to write the GCF out front. 8 divided by 8 cancel each other out. X cubed divided by x squared is just plain old x. Then I still have my minus. 64 divided by 8 is 8. X squared and x squared cancel each other out. So that's what I'm left with for there. And then x and negative 8. The GCF of those two is just 1. So I'm going to take a 1 out of those two. So we got x minus 8. Now what I'm going to do is I'm going to look at these two terms. 8x squared, parentheses, x minus 8, and 1 times the quantity x minus 8. I'm going to take the GCF of that out. So what they have in common is x minus 8. So I'm going to take an x minus 8 out. And when I take the x minus 8 out, I will be left with 8x squared plus 1. Now to finish solving these problems, we actually have to solve. We got to set them equal to 0 and solve. So x minus 8 equals 0. And we're going to solve this. So we got plus 8. So we got x equals 8 here. And then this guy is 8x squared plus 1 equals 0. Because it's a quadratic, and you know because it's degree 2, I got to use my quadratic formula or my factoring. So this time I'm going to use the quadratic formula. So I have A is 8, B is 0 because I don't have an x, and C is 1. So it's the opposite of B, so the opposite of 0. Actually, I'm going to put this up higher so that I don't run out of the room. And let's do it in green so you know. So we have the opposite of 0 plus or minus the square root of 0 squared minus 4 times A times C all over 2 times A. So the opposite of 0 is nothing. I don't have to write that. So it's just plus or minus the square root. And then if I plug all this stuff in my calculator, I get negative 32. Okay, so this is the square root of negative 32 over 2 times 8 is 16. And then I got to simplify the square root of negative 32. So I'm going to take this off to the side and simplify it. So the first thing I notice is it's negative, so I'm going to take out a negative 1. The square root of negative 1 is I. The square root of 32 is, we got to break that down further. So the biggest perfect square that fits into 32 is 16. 16 times 2. So square root of 16 is 4, so I have 4i square root of 2. And I'm going to plug that back in. So I end up with x equals plus or minus 4i square root of 2 over 16. And I got to take the GCF of these two out. So the GCF is 4 this time, so I'm going to divide out of 4. So I got x equals plus or minus 1i square root of 2 over 4. So my roots are 8, 1i square root of 2 over 4. Well, let me draw the over 4. And my other root is negative 1i square root of 2 over 4. So those are my 3 roots for this problem. So that's kind of hard to see. So that was hard to see, so I just wanted to show you what those answers were again. They were 8, 1i square root of 2 over 4, and negative 1i square root of 2 over 4. So those were my roots. And these are equal to x. Okay, so let's do example 2. So again, we're going to start by grouping them because it's factor by grouping. So I'm going to group the first two terms because this is already in standard form. And I'm going to group the last two terms. So my GCF of 12 and 21, 12x cubed and 21x squared, I could take a 3 out of both of those, and an x squared, so 3x squared. So when I take a 3x squared out, I'm left with 4x minus 7. Okay. With 28x and negative 49, I could take a 7 out of both of those. 49 doesn't have an x, so I can't take an x out. So I have 4x minus 7. Okay, now these two. Remember, I should have something in common. I do. It's 4x minus 7. So 4x minus 7. Okay, so when I take that out, remember the GCF goes first. And then I write what's left. So I've got 3x squared plus 7. Okay, so this is totally factored. Now all that's left to do is I need to do the, I need to solve this. Okay, so I got 4x minus 7 and 3x squared plus 7. So 4x minus 7. Is it minus 7 or plus 7? This was plus 7. Oops. No, it was minus 7. Minus 7. So 4x minus 7. And the other one was 3x squared plus 7. 3x squared plus 7. Okay, so 4x squared minus 7, I'm just going to set it equal to 0, and I'm going to solve it. So I add 7 on both sides. So I got 4x equals 7. I'm going to divide by 4. So I got x equals 7/4. Okay, this other guy is a quadratic because it's degree 2. So I got to do the quadratic formula. So a, b, and c. A is 3. I don't have an x this time, so it's 0. And c is 7. And then I plug it in. X equals the opposite of b, plus or minus the square root of 0 squared, b squared, minus 4 times a times c, all over 2 times a. So here I've got the opposite of 0 is nothing. So I've got plus or minus the square root. Let's see, so I got to type that whole thing into my calculator. So I'm typing in 0 squared minus 4 times 3 times 7. And I end up with negative 84. And then this is all over 6. Okay, so this is where I take my square root off to the side and I simplify it. So negative 84. I'm going to pull out a negative 1 first. The negative 1 is going to give me an I. Then I got to find what perfect square fits into 84. So the biggest one is 4 and 21. So the square root of 4 is 2. I still got my I. And 21 doesn't have a square root, so I just leave it as is. So if I plug that back in, I have x equals plus or minus, and then I plug in my 2i square root of 21. And this is still over 6. Then I'm going to take the GCF of 2 and 6 out, which is just a plain old 2. So I have x equals I square root of 21 over 3. And this is still a plus or minus, sorry. Okay, so my last roots, I've got 7/4. I've got I square root of 21 over 3. And I've got negative I square root of 21 over 3. So my three roots are 7/4, I square root of 21 over 3, and negative I square root of 21 over 3. Go ahead and try example 3 and 4 on your foldable.